Welcome to the Unit 4 review video. On this section, we're going to be talking about systems of equations. First, we're going to graph them, then we're going to use something called substitution, and then elimination. So I'm actually going to do the middle example first. This line right here, I'm going to graph the top one in green. It starts at -2 because on the y-axis, because that last number is the y-intercept. Then, it has a slope of -3/4. That means we go down 3 and right 4. Oops. Don't do my mistake. I didn't go over 4, I went over 3 first. So we go there. And instead of going down 3, right 4, I could also go up 3, left 4. It is a good idea to draw your slope as many times as you can fit on your page so that you have the straightest line possible. And because when I go to graph my next line, I want to see where they cross. Here's what happens if you do it correctly. So this one isn't y equals. So what I have to do is I have to find the intercepts by doing 2x equals -10 and -2y equals -10. So I'm basically covering up the y spot. That's where my 2x equals -10 comes from. Then I cover up the x part, and that's where my -2y equals -10 comes from. Then, over here, I divide by 2, and I get x equals -5. So I go to the x-axis and put a point at -5. Here, I divide by -2. That's +5, because there's a -10 divided by a -2. Two negatives divide to a positive. So then I go to where y is +5, and I connect those 2 points. And see how this line goes straight through that point? That's my answer, this point right here. That point is -4, 1. Done. Now let's talk about substitution. And I'm going to go straight down the middle. For this one, when you are trying to use substitution, look for the variable all by itself. Then you're going to take this part and substitute it. It is a good idea to circle it now because it's going to be important later. Since this is what y equals, I'm allowed to replace it with the y in the other equation because they're the same thing. So then I have 3x plus 4, and instead of y, I'm putting this. And it still equals 23 at the end. What that's done is now I have an equation with only x's. That we can solve. We can't solve an equation with x and y. So what I'm going to do is I'm going to take this 4 and I'm going to distribute it, just like I did in Unit 1. Then I'm going to add that 12 to the other side. And as I do that, that's going to give me 35. I'm also going to come over here and say, hey, 3x minus 8x, they're on the same side already, so don't do any fancy opposites or flipping or anything. Just simply 3 plus -8 is -5x. And then you divide by -5, and you get x equals -7. That's the first part of your answer. The other part is the y value. Remember how I said we circled this for a reason? Or technically I boxed it. That's because you're going to take this -7 and you're going to plug it back in right there. -2 times -7 minus 3. That's 14 minus 3, or 11. So y equals 11 and x equals -7. This is my 7-11 problem. Now let's talk about elimination. Up here, we replaced this or substituted it to get the equation to only have x's. Down here, we're going to try and use multiplication to eliminate a variable. And I'm going to go ahead and actually skip to number 9. So for number 9, you'll notice that my x's are -3x and 9x. Our goal is to take the smaller one, in this case that's the top one, and multiply it by something so that this turns into negative 9x. Because then I can add these two equations together and that will cancel out. Now, here's the question you have to decide. Negative 3x times what will give me negative 9x? Well, it still needs a negative, so you don't need to multiply by another negative. Then 3 times 3 is 9. So I need to multiply this by 3 to get this. The thing is, you're not allowed to just do it to this one little piece. That would be pretty dang easy. I have to multiply it to these two pieces too, to keep everything balanced. So 5 times 3 is 15, 12 times 3 is 36. Then I'm adding these two things together. Those cancel out. Negative 2 plus 15 is 13, y. And 3 plus 36 is 39. That's most of the work for elimination, because then you just divide by 13, and you get y equals 3. Be careful and make sure you know whether this is x equals or y equals. Then you take this and you plug it back in. Does not matter which equation, I'm just going to pick this top one. So I'm just changing the y to 3, because y equals 3. Now, this is really just 15, right? 5 times 3. I want to get rid of it to the other side, so I'm minus 15. And I have negative 3x equals 12 minus 15 is negative 3. Well, divide by negative 3 on both sides, and x equals 1. Make sure that your answer has an x and a y. Now let's move on to Unit 5. Exponent rules. I'm going to try and explain these as simply as I can, and I'm actually going to, do numbers 4 through 7. So I'm going to start with number 4 to get this one kind of out of the way. See how there's a negative exponent here and a negative exponent here? Negative exponents make terms flip. So that means this one has to go to the top and this one has to go to the bottom. The c squared has a positive exponent, so it stays right where it's at, but then the b4 moves up top and the a5 moves to the bottom. Once they flip, they don't need the negative anymore. So the whole goal is to not have any negative exponents by flipping them. And that's it. On number 5, you'll see some parentheses. This works just like regular distribution, where you multiply all of those exponents by 2. The only one that doesn't get multiplied is this 5. It's a regular number. For the 5, you're doing 5 squared, or 5 times 5, which is 25. Then I'm going to have my w, but now its exponent is 6 times 2, which is 12. And my x, its exponent is 3 times 2, which is 6. And lastly, my y, its exponent is 5 times 2, which is 10. And that's it. Over here, I have some division. 21 divided by 7 is still 3, just like it always has been. Then, here's the easiest way to solve the next part. Are there more w's on top or bottom? Top. How much higher is 18 than 3? 15. Done. You can also subtract them if that helps. And on 7, we have 6 times 2, that's 12. And then I have 11k's over here and 4k's over here. If I'm trying to put these together, that means I have 11 plus 4, or 15. For my j's, I have 5 and 2. Well, 5 plus 2 is 7. Notice how I only added the exponents on the k's together and only the exponents on the j's together. They have to be the same variable. Okay, let's scooch on down just a little bit. I'm going to go ahead and do 11 because I know it throws a few people off. This one has a negative exponent, so it has to flip. The 9 stays on top, but the m and the 13 are going to go to the bottom. The 13 just isn't negative anymore. Done. Okay, I'm going to pick one more for us to try. Let's see. Let's do number 18. I'm going to do just the top part first. 6 squared is 36. And then the x is going to be squared now too. And the y already had an exponent, so it gets multiplied by 2 and becomes 6. The bottom part stays exactly the same. Now, here's the question. What is 36 divided by 9? 4. Are there more x's on top or bottom? Bottom. 5 is bigger than 2 by 3. So x to the third stays down there. And there are more y's on top by 2, so y to the power 2 goes on the top. And that's it. Now let's talk about square roots or radicals. On your notes sheet, you're going to want to have the perfect squares. I'm going to write them down really quick. You need to take a second to do the same. Pause the video if you need to. Sorry, I ran out of space. So 4 through 100. What you're going to do is try and find a number that you can divide 147 by. So 147 divided by 100 and 81 and 64 isn't a whole number, but 147 divided by 49 is 3. Then you do the square root of 49, which is 7. And it gets to come outside because you already did the square root. And that is how you simplify a radical. This one was a little bit easier because 32 is 16 times 2. Got a little ahead of myself there. And the square root of 16 is 4. That's it. Go ahead and give the rest of those a shot. I'm going to move on to Unit 6 with you. Unit 6 is probably one of the more natural math sections. What that means is you can use the logic you already know to solve most of it. So I'm going to do numbers 2 and 3. Notice how this one has a plus in between, and this one has a minus in between. Anytime you see that minus in between, think of it like a -1 and multiply it to everything afterwards. So that's going to make this -2x, -x cubed, and +4. Okay? So now what I'm going to do on both of these is I'm going to combine like terms. When it says standard form, that means your highest exponent has to go first. So start by looking for your highest exponent. For this one, that's 3x squared. There's no other x squared, so that stays as 3x squared. For this one, that's the x cubed. There's no other x cubes, so the -x cubed stays there. Then I'm going to look for the next highest. After x squared comes x. I have 14x and -5x. 14x plus -5x is 9x. Then -8 plus 3 is -5. Now I can go back and double check because I circled things and crossed them out. I used all of these terms, so I'm good to go. That's my answer. On number 3, after the x cubed goes x squared. There's only one x squared and it's right here. Since it's 3x squared, not -3x squared, I put a plus in between. Then I have -4x and -2x. -4 plus -2 is -6. And lastly, I have my 7 and my 4. 7 plus 4 is 11. Now let's talk multiplying. By the way, all the rest of these are very, very similar. Just make sure you go highest to lowest exponent in order like this. Also, number 1 is the same as number 3. So I just did 3 problems for you, really. Alright, let's talk about how to multiply. When you're multiplying, like I'm going to take this and multiply it here, you're going to multiply the regular numbers and add the exponents. 3 times 4 is 12, and x squared times x squared, now there's 4 x's in that one, because I'm taking these 2 x's and putting it with these 2 x's. Then 3 times negative 5 is negative 15. I have x squared here and another x here. That makes x cubed. 3 times 6 is 18. I have x squared from here, and there's no other x's here, so it keeps the x squared. If you have 2 sets of parentheses like this, I highly recommend doing the box method, where you take one of them, and the other one goes on the other side, going down like this, and you turn it into a box. All this does is it helps you to keep track of it. If you don't like the box method, here's the other way of doing it. Take 4x times both of these, then take 1 times both of these. The box is just there to help you organize. You're not doing any different math. Because I'm still multiplying 4x times 2x, I'm just doing it inside of this box. 4 times 2 is 8, and x times x is x squared. 2x times 1 is 2x. 4x times 6 is 24x, and 6 times 1 is 6. The other thing that the box kind of helps with is, after you do that, you're supposed to add these two together because they're in the diagonal and they both are regular x's. The 8x squared stays. 24 plus 2 is 26x, and then the 6 at the end. Very nice. One last thing I want to talk about is this one right here. This does not mean we're actually going to square any of these. What it means is when we go to draw our box method, like on the last problem, they both are 5x minus 3. And then you solve it just like you did this one. This square just means you draw it like a square, where this side and this side are the same thing. Okay, I'm not actually going to solve that one all the way out. I'm going to move on to factoring. When you are factoring, and this is something you might want to add, you need to find 2 numbers that multiply to the last and add to the middle. What that means, unlike 14, you're going to put those 2 numbers in parentheses with x like this. And I need to find 2 numbers that multiply to negative 20 and add to negative 1 in the middle. Let's go over things that multiply to negative 20. We've got negative 1 and 20, negative 2 and 10, or negative 4 and 5. Those are our only options. We want one that adds to negative 1. Negative 1 and 20 makes 19. Negative 2 and 10 makes 8. And negative 4 and 5 makes 1. We want negative 1, so all I have to do is make the 4 positive and the 5 negative. And that right there is my answer. Let's go over one more. Over here, I need to find 2 numbers that multiply to 12, 1 and 12, 2 and 6, or 3 and 4. And I want to pick the ones that add to negative 8. Well, that looks like it's 2 and 6, but they add to 8, not negative 8. The only way to fix that is to make them both negative. Because then, negative 2 times negative 6 is still 12. And they add to negative 8 properly. Now let's go over factoring by grouping. Over here, we're going to group together the first 2. And then we're going to group together the second 2. That's what grouping means. For the first 2, you need to decide the biggest thing you can divide both of these by. There's no number over here in front, so there's no number on this, but I can divide them both by x. In fact, I can divide them both by x squared. Since we want the biggest thing possible, we're going to go with the x squared. That leaves me with x minus 5. Because if I take 2 x's out of x cubed, now I just have x. And if I take the x squared away from 5x squared, I have just 5. Then I do the same thing on the other side. I can divide both of these by 8. But if this is a minus, this will be a minus. So I'm really dividing them both by negative 8. Negative 8x divided by negative 8 is x. 40 divided by negative 8 is negative 5. What has to happen with grouping is these two things match. Because now our greatest common factor is x minus 5. And if I take that away, all I have left is the x squared minus 8. Like that. And that is your answer.